Convergence is where several transmitters released from different cells can act on the same postsynaptic cell. In this case, from the submucous plexus of the intestine, we have alpha-2 receptors for noradrenaline, delta receptors for opiates, and also receptors for somatostatin. They all led to the opening of the same potassium channel. If you opened them by activating one receptor, you couldn't open them anymore by activating the second or the third receptor. So this was the idea of convergence of many different receptors or transmitter action onto a single channel. I think that was probably the essence of this many transmitters, few channels paper. Of course, we now know from the molecular basis there are actually many different variants of those channels. But I think fundamentally still, with our now molecular insight, we know that many different receptors converge onto a single channel. So there are so many different peptides and transmitters, but they finish up doing the same thing at the cellular level. In divergence, a single transmitter, such as acetylcholine, can act on nicotinic or muscarinic receptors on postsynaptic cells, and there are many subtypes of each. Shown here are M2A and M2B, as they were known in the 1980s. I think when it became clear that there were many subtypes of muscarinic receptor, all of which did different things to the postsynaptic cell, then you have a situation where a single transmitter, acetylcholine, can diverge to affect an M1 receptor or an M2 receptor or an M3. In fact, there are now 5 muscarinic receptors. Yeah? I mean, what we were finding was not 2 different muscarinic receptors on the same cell, but the same set of presynaptic nerves could release acetylcholine and activate M1 receptors on one cell and M2 receptors on another cell. When you activate the M1 receptor, the cell is excited. It's depolarized. When you activate an M2 receptor, the cell is inhibited because potassium channels are opened. So I think this is really the essence of the divergence idea, that a single transmitter can have a multiplicity of effects on postsynaptic cells. And now that's taken for granted. ATP can act on P2X receptors and P2Y receptors. You often see them on the same postsynaptic cell. Acetylcholine, nicotinic and muscarinic. Noradrenaline and dopamine are interesting because there's no fast ligand-gated ion channel that is opened by noradrenaline and dopamine. They have the slow actions, but not the fast action. But then GABA, for a long time we thought that all that GABA did was directly have a fast action to open chloride channels. But now we know through GABA-B receptors that it also has a slower action to open potassium channels. So the same transmitter, the various examples that I've given you, can have a fast synaptic action and one or more slow synaptic actions on the postsynaptic cell. This was really the essence of the divergence.